Good morning, everyone. I am Emertxe from Rajkin College, Sonbhad. As a part of my embedded system online internships at Emertxe Technologies, I developed an EV ADAS dashboard using STM, Blue Pill, PicsimLab, and Python dashboard. This project demonstrates how embedded system can be used for real-time electrical vehicle monitoring and advanced driver assistance system or ADAS. Next, real-time EV monitoring and ADAS. Here is my project. Firstly, I am thanking to Emertxe team giving such opportunity to that time of real-time project, waiting on the following tools. These are STM32 Blue Pill, PicsimLab, Python dashboard, real-time EV monitoring. Firstly, I represent that the introduction. Embedded system Emertxe EV transfer store. So basically, this video is on the EV ADAS dashboard project developed from the uh, given data. These are the project's highlights. STM32 Blue Pill, which is the model I used, real-time EV monitoring dashboard, UART, and motor temperature monitoring. Now, interview overview. So hands-on the practice system in terms of STM32, this is the full model which I used to, and this is the library. STM32 QIDD to electrical full advanced system. So there are five coding models, ultrasonic sensing ADAS, PicsimLab, and Python dashboard feed. So these are the tools and development environment. STM32 QID, Python, PicsimLab, VSP plus Teraterm. I will show all the terms system architecture. So these five modules, which are even sensors, EV control, ADAS plus fault, UIT cell, Python dashboard. These uses the timer as a TM1, TM2, TM3. These are the TM5 using GPU, GPU and ADC pin mapping. Every analog and digital signal has a defined analog inputs. Here I use the same pins in the model. I will show in different form, just like the pins PA0, PA1, PA2, P3, and for digital PB0, PB1, PB2, PB3, PB4, P5, PB8, PB9, and P11. These are I used for GPU and to connect the board. And I use ultrasonic driver HCSR3 came to free running counter using Microsoft Stopwatch. This is usually for the using for the triggering the pulses sequence for sensor 2 microsecond low settle 10 microsecond trick pulse pole equivalence pole echo falling edge to distance pulse which us into speed. This is the formula which have to calculate the for the speed and his gap between the 30 microsecond. Actually use to HRCR says real time on a 50 microsecond. Team 2 had a this is the code of the whole team get content post until vertex. Timer based real time scheduling to interpret driver loops. So firstly just I tell you that team 1 for 10 microsecond, team 3 for 100 microsecond, team 2 for free running. These are the time which actually calculated. In one T1 we have controlled the EV control loop, in team 3 sensor and ADAS loop, and in team 2 microsecond clock. This is the some actual ADAS systems. The problems. Why smart EV dashboard? Actually, the real power bottle. The problem is modern electric vehicle generate enormous volumes of real-time sensors that actually based on the SOCs and without ADAS system they are not performing well. A single operator cannot track all parameters when it conclusion blind spots. There are too many blind spots that are not covered by them. So the problem and I have given solutions here. EV ADAS dashboard system. Firstly, and real-time speed association and range monitoring, ADAS collision and blind spot detection, motor temperature and falling lighting, live path and dashboard by UART, guide alarm system, drive mode control. These are of three types: eco, normal, and sport. Actually, this is the main solution which actually we have given to control my EV ADAS. real industry versus our project and its flow component. In simulation stacking real industry components, our project equivalent real pressure, wheel speed, proximity sensors, potentiometers, ADC, automatic automobile, fixing lab simulation, ECU, vehicle control unit, VCU, which is actually used mostly for that, and STM32 Blue Pill, UART, industrial clusters, and other hand the Python microprocessor code. In this dashboard we use OBD, diagonal port, etc. reader, UART cell, port cluster, multi-turn buzzer. Yeah. Next, EV controller, state machine. Here we use the ready drive-in recon with a fault override. In this, we have the vehicle state machines and torque and rhythm walking. Here, the formula for the drive and torque acceleration percentage divided by 100 to 150 Newton meter into mode scale. In which mode it is given, basically is eco, normal, or ADAS. Mode scale eco 0.6, normal 1. This is the mostly speed and the sport in 1.3x. This is the above region threshold brake percentage. This is normal to the 82 Newton, 80 Newton meter. EV controller is speed, power, and associate on the simple phase model that still behaves strictly. So, firstly, we have the control speed by Euler integrations, acceleration equal to motor torque into drag upon mass vector. This is the basic formulas which we use. Associate integration battery drains by the power into these are only the formulas. Motor temperature heats up. Actually, if the motor heat rapidly or fastly, then how to manage it? Actually, it depends on that. ADAS collision warning and TTC turning ultrasonic distance plus speed into a graded alarm. TTC is used to time to collision. It did basically used to do that just time that just in the model I was saying the front distance and low distance and front low left and right distance. So I have commonly computed moving. So otherwise TTC had 90.9% saves or not climbed to 0.92 range. It is the range on that dashboard. So graded collision warning critical in front less than it is actually 20 centimeter and warning in front 50 centimeter less than to it actually work as it blind spots. The remaining ADAS checks and how point cover at a vehicle. Actually, you know the blind spots that are there to the space which are not seen by the driver to check up the uh, other cars are moving. So for that, we use blind spot detection system. So this measures only to the 30 centimeter to 20 kilometers per either left to right. That actually warns you to the critical warning adversely blind spot, overspeed, or non-desert attack, fault detection, 3 point sources, motor over temperature, critical loss, or season kernel, faults are bit marks. Any active fault forces the vehicle into the state fault auto clears. UART commands, a live command interface for defining every subsystem. BRs and UART and the solo processes. In this, there are some differences which are made. Mode economy sports switch drive mode. In this, they are given that the speed set, shock set, obstacles and fault inject motor, status and preset. In the switch drive mode, inject the taxi speed, inject battery SOC, sampled of font obstacle, force of fault, condition, full stack dump, help or reboot. Stated terminal and Python expert. In this UART terminology, basically not as a compact main loop status runs. It shows the working or not. In the Python password, BSP creates a virtual series port pair and the password visualize speeds 40% is actually this is shown the whole body to the distance left, right, and front distances. Teratom runs basically use Teratom to Python dashboard. Structured terminology in Python also breaking point for stable to URT and actually this is second time. These are the key learnings. Multi-rated real-time scrolling using independent hardware timers, 10 meter per 100 improved. Yeah, I have used 10 microsecond, 100 microseconds in two times and actually calculated between them. So designing a clean model boundary, we control ADAS, or cell that all the thing. Now physically motivated modulating intra-base speed, copper loss, power terms, and hysterias and bitmarks technologies, interrupt-driven UART, end-to-end system thinking from the IDC signals to now I have also used some that tools I used here. Here is the STM32 QID, and this is PicsimLab. QCon that the Teratom that are used and use VSP and VSP here. So here we have to write all the firstly we select the files here. Just in this, I have selected the files. In the, these are the PicsimLab setups and STM32, and these are the my files. All the files where links just like this. The first move link. Here I'm a project is I click here see project and all my project are shown below. This type of blink one blinks, ADAS mode, teardown, timer one, timer two. This is the ultrasonic sensor ADAS. All projects are there in the file and my other downloads here in my text and if teardown Python does what teardown. These are the some all are given by the Emertxe team. So this is the item 34 here. That I will show you the HTML32 project. This is downloading. After that, we conclude and we have given the board. Actually, HTML32 board. Actually, it takes too much time, so cancel it. Mm, it is open. This type of board. Here I select STM32, which I have the Google model app for. This is the model. Six here. We have next. So project name I finish. Hmm, here It is the lab or this GPU input. The pins are there. Here, from there, we use the product. Can you cut it? You see, because I have only shown all are the projects and I have the edit test blank bling one blinks ADAS. These are the my projects. All projects are there. In SRC, I have the all my main fault codes that are given time on all my projects are there. This is the code for this. We have to go main and here we have to build the project. People in the proof, the header are given the 0 errors and 0 warning. After that, we have the properties, enter properties. After that, convert to binary for apply and close. Then code for PicsimLab. Here is my PicsimLab. After that, file. In the this is the spare part of the PicsimLab. This is my PicsimLab. Here, file load bin, ADAS, open. So that in virtual terminal, you have to all these output in virtual terminal. Now, for this is my working one. The front I have come. The LEDs are on, off, on here. After that, if this is the model, these are the potentiometers. These are LEDs. These are the buzzer. This is a virtual terminals. These are the models front, left, right. Now after that, STM32, I completed the code here. What is cells? These are the codes. All code here. After that, EV control. Now we have to go to these are my Pixim. This is the PicsimLab. In this, we have to go to spare parts and select all the things that we actually need. Right, it gives the virtual terminal output. After that, now we use common paradigm to file. After that, we have used idle cell. Now, after all these coding and the project demonstration full, then we have to ready for the EVDAS dashboard. This is my EVDAS dashboard. Here is a given a speed and the speed history. This is the 25 to increasing and normal mode 167. This is my battery percentage. This is my EV car starting word I view. Now I have to change it. So go in spare parts, change the speed, the brake pedal, increase the brake pedal, acceleration, temperature, keep low. Now go to here, just like that. The speed is decreasing by brake and the entire world shows the V matrices. The left 86 and the dashboard by iWord, it is showing that the distance for it. If we enable brake, full brake, acceleration, and temperature high, then it shows full acceleration, brake, the distance covered, and VSTR. It shows that the car behind right side and the left side, and the speed is increasing, so the car can touch the other car. So this is my project on EV dashboard. Thank you everyone, and thank you especially for the map Vijayalakshmi give me. Thank you.